Hello, Math 005. What we're looking at today is the very last unit. We're starting with 5.1, exponents and their properties. Exponents is something you're probably at least a little bit familiar with. We're just going to dive in a little bit more deep with them and go over what it means to simplify exponents and just really get to learn all the exponent rules, if you will. So the first one, let's review, and it says recall what you already know about exponents. The nice thing about exponents is you don't have to just memorize the different rules. If you understand the exponents and what they mean, it makes them a lot easier for you. So let's go ahead and just walk through without knowing anything about really the exponent rules themselves, but just our basic knowledge that we already have. Let's see if we can go ahead and simplify some things here. So for the first one that we have it says simplify. We have x squared times x cubed. Now, what we know about exponents, we can take just this x squared and create from that x times x. We know that x cubed means that there's three x's. So that would be x times x times x. Now you can see that between the two here is a multiplication sign, so we're going to put the multiplication sign back in between them. Now, when we go ahead, I'm going to put equal sign in front of all those. Now, when we go ahead and count all them up, we have the base of an x, but now there's 5 of them all together. So you can see that this first problem here, x squared times x cubed, would simplify to x to the 5th. That's one of the first things we're going to do. Now, I want you to take a minute and I want you to pause the video and I want you as best as you can to try to work through the following ones here. Again, even if you're not quite sure what you're supposed to do, think about, okay, what does it mean if something is cubed? That means there are 3 of these. And then work through this one. Letter C, you have 2 x's in a numerator, 3 in the denominator. Think of what you know about canceling. In letter D, you can see that the first one you have 2 x's, and then you have 3 of these whole things. So expand that out and see if you can simplify. Letter E, you have 4 x's in the numerator and 1 in the denominator. Again, think about what you know about canceling. And the last one, you have this x cubed over y, or x squared over y cubed to the 3rd power. Again, you have 3 of everything inside the parentheses, so go ahead and expand it out. So I want you to pause the video and try to simplify everything as best as you can, and then come back and check what you did with what I did. Okay, you can see my answers here. If you want, you can either pause the video and look at all my work. I am going to just quickly walk through what I did for each one. So in letter B, we start with x squared cubed. That means we have 3 of these. So we have x squared times x squared times x squared. Now, just from what we did in the previous one, we know that if we have x squared, that's the same as x times x. So I rewrote each of these x squared as x times x, and then I count them all up to give x to the 6th power. Letter C, we have x squared over x cubed. Again, if we expand them out to get x times x in the numerator, and then x times x times x in the denominator, and then we can cancel these factors of 1. So x over x cancels, and another x over x cancels. We're left with 1x, and it's left in the denominator, so we have to make sure we put a 1 over top of that to show that that x is in the denominator. Letter D, x squared, and then we have all this cubed. So first thing is I took the x squared and rewrote it as x times x, and then I wrote 3 of these x squared y's. Now, we see parentheses here. They're going to be the same thing as multiplication. So what I did in the next step is I just rewrote everything with using a dot for multiplication instead of the parentheses. The parentheses aren't doing really anything here aside from saying we're multiplying. And then each x squared y is the same as x times y. So I just did that for all 3 of those. And then what I did is I just counted up all my x's. 1, 2, 3, 4, 5, 6, 7, 8 x's. And in the end, we had 3y. So x to the 8th y cubed would be what this is simplified. Letter E, x to the 4th over x. This one's very similar to letter C. I expanded it, canceled a factor of 1. I'm left with 3 x's, or x cubed, in the numerator, but I don't need to put a 1 under that because it stays in the numerator. And lastly, I didn't write the problem out here because I was running out of space, but we have this x squared over y cubed, and that's to the third power. So we write 3 of them. Then you could expand it out like I did in all these previous ones, but what I did is just counted it from here. I have 1, 2, 3, 4, 5, 6, so x to the 6th, and 3, 6, 9y, so y to the 9th. If you don't understand anything, please email me and ask for clarification, and I can go into more depth about any of them. So now that is pretty much a big sum of all the exponent rules. But what we're going to be doing now is taking them step by step and really learning what these rules are. So the first one that we have here is multiplying powers with like bases. That's going to be very similar to what we did in problem A up here. We say the bases are going to be what we have for the x's here, and we're multiplying because the operation between them is multiplication, and we have to figure out what do we do with the powers. And looking at this example, we started with x squared and x cubed, and we ended up with an x to the 5th. So that tells us that we have to add those bases. So whenever we have a base of, we'll say a being raised to the mth power times a base of a to the nth power, that's when we keep the same base and then we add those exponents. That's going to be the rule that we want to look at. So for this example, you want to look at the base and then add the exponent. So in problem A, the base here is 2, so we keep the 2, and then we add the exponents. That's supposed to circle them, but you can't see it too well. And then we add the exponents, so 3 plus 8. And we get 2 to the 11th power. We're just going to leave it like that for now. The next one. Here we have some variables and we have a sum. However, this r plus s, that is still going to be the base. So whenever we're working through these, we do not change the base at all. We just add the exponents. So very similar to how we've done the other problems. So again, we keep the same base. 7 plus 6 is 13. So that's what we'd do for this one. Now, letter C, we have multiple bases. We have A's and we have B's, and we have actually 2 A's present and then the B's as well. When we simplify, you can only write one of each base. So our simplified answer should be A to some power and B to some power, but you can only have one of each. If it's easier for you, what we can do is rewrite these without the parentheses, just so we can see them as all one thing. Now what you can also do is reorder it, because remember, commutative law allows us to change the order of a multiplication problem. And you can think of the A's and the B's themselves being multiplied together. That's how you're able to change the order here. So we have A cubed times B squared times B to the 5th. And again, add your exponents, so A to the 6th power times B to the 7th power. 3 plus 3 is 6, 2 plus 5 is 7, and that is our answer there. The next thing here, we want to prove that these two statements are not equal. The reason being is students often make this misconception. So we want to prove that they're not equal. That way, if you're ever taking a test or something and you forget, you can try this out to see if they're equal or not. And the way we're going to do to prove it is we're going to let R be equal to some number and S be equal to some number. I want you to choose 2 different values for R and S, it doesn't matter what they are, and then substitute them into both sides of this to see if you get the same thing. I'm going to do it for R is 2, S is 3. Again, you could choose any values you want. What I want you to do, pause the video and try it out, see if these two, well, I'm going to say prove that they're not the same. Okay, you can see that I used 2 and 3 and substituted them in, and we simplify, we get 25 is not equal to 13. So therefore we know that these two statements are not equivalent to each other, meaning you cannot distribute this 2 to the R and S to simplify it. That's one thing we need to be very, very careful with, and we're going to look more into that as we move through this section. Okay, next page. Similar to, let's see, we looked at letter C here and letter E here. So that's going to follow those back again. Sorry for flipping back and forth. If we look at this one right here, letter E, we have x to the 4th over x, and there's no exponent written there, but when there's nothing written, we think of that as being a, let's go back, sorry. We can think of that as being a 1 right there. And we looked at our final answer was x to the third power. What we're doing here is you're subtracting those exponents. First page, when we looked at this example at the bottom, we could not distribute this exponent. The reason being is because there was an addition as the base. Dividing powers with like bases. And this one's going to be very right there. So when we divide powers with like bases, what you can see, actually, I'm going to setting up as division. So we can take this problem here and say, okay, we have 7, keep the same base, and then 9 minus 4, which would be 7 to the 5th power. Now, if we were to expand it, say we forget what the rule is. That's why it's important to understand exponents. That means we have 9 sevens. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're dividing it by 4 sevens. So 1, 2, 3, 4. Now when we go to cancel these, we know we can cancel 1 for 1. So that cancels, that cancels, that cancels, and that cancels. And then you can see here that you are left with 1, 2, 3, 4, 5, which is our answer of 7 to the 5th power. So the rule here that we're talking about, very similar to the rule on previous pages, if you have a base of a being raised to the mth power divided by base of a to the nth power, you keep the same base, but you subtract their exponents, just like we did there. Again, if you forget, you can expand it out just like I did here. I want you to go ahead and try letter B. So pause your video and try letter B. Okay, when we look at this, we have 5a, because this is our base, and we keep the same base, and then 12 minus 4 to give us 5a to the 8th. Now, if your answer looks like this, it's not going to be completely correct yet. And what's the difference here? Right, I forgot my parentheses. You must have parentheses around the 5a. The whole base is 5a. And why that makes a difference is going to be this right here. If we have 5a, I'm going to change the numbers a little bit just to make it easier. We'll say to the 3rd power. If we were to expand that, we would have 3 of those. However, if we do not have parentheses, it would look like this. The cube would only belong to the a. So you just want to be very careful with parentheses. The parentheses are very, very important here. So now looking at the next one, letter C, you'll notice that we have 2 that have a base of P, 2 with a base of Q. We know we only want one, and then we have a 4/6. What I always recommend doing whenever you have multiple things in one fraction like this, split it into 3 separate fractions or however many things you have. So for example, I'm going to set up 4/6 and then P to the 5th over P squared, and then q to the 7th over q. Now we can follow our rules because we have problems that look a little bit more familiar. Now the first part of this, the coefficients, we have 4/6. We know how to simplify that. These don't have any exponents. They're not like bases, so don't use any exponent rules. We're just simplifying that. 4/6 simplifies to 2/3. Now we can apply the exponent rules. We have p to the 5th minus 2. I'm going to put a numerator of 1 under that just so we can remember that that goes in the, or I'm sorry, denominator of 1, because we need to remember that goes in the numerator. And then we have q to the 7th minus, and again, if you forget, if there's no number, we assume it to be a 1 there. So 7 minus 1, and then again, it has a denominator of 1. And then we can simplify this. So we get 2/3 times p to the 3rd times q to the 6th power, and that would be our answer. You could also write this as 2p cubed q to the 6th, all divided by 3. Either way is perfectly okay. Okay, the next idea here is 0 is an exponent. What I want you to do first when we get to this problem, I want you to type a couple things into your calculator just to experiment. I want you to type this exactly as you see it into your calculator. I also want you to type letter D into your calculator exactly as you see it and see what you get with those. Okay, when you type these in, you would see with letter A you get a 1. Letter B, you should get a -1. If you did not get those values, double check you typed them correctly with the parentheses, and for letter D without the parentheses. The reason being is 0 is an exponent. Any base raised to the 0 power is always going to be equal to 1. So any base of a raised to the 0 power is always going to be equal to 1. Now you're saying, okay, well, how's letter D a -1 if we're raising it to the 0 power? And that's because of the deal of parentheses and what the base actually is. So in this first one, let's actually start with letter A. The base here, the base of this problem is a -9. So that whole thing is the base. Whereas in letter D, the base here is just a +9. Oop, excuse me for a second. Okay, now back to the examples here. So letter B, 3x to the 0 power. What we want to really think about here is what is the base of that 0 power? And for this one, we see that the base here of that 0 power is actually just the x. So just, let's see if I can get in here, just this part is going to be equal to a 1. Therefore, we have 3 times 1, which is just going to be equal to 3. Now for letter C, since we have parentheses, that whole thing is going to be the base. So that whole base raised to the 0 power is equal to just the 1 there. So that's what you want to look for, is what is the base of the 0 power? Whatever the base to the 0 power, that's equal to 1. The next thing, raising a power to a power. Before we look at the rule here, let's go ahead and work through this example. We have m squared to the 5th power. That means we have 5 of those. So if we were to expand this, we'd have 1, 2, 3, 4, 5. Oop, here I'm saying what I'm 5. Now, if we were to expand each of these, like we did in the previous ones, we know that m squared would be m times m. If we were to do that for all of those, and then we could add them all up, we'd see that we'd have 2, 4, 6, 8 m to the 10th power. Now, it's not going to be feasible to write things out all the time, so the rule here that we're talking about is anytime you have a base of a raised to a power, and then that is being raised to a power, we want to multiply those two powers. So looking at this one, m squared to the 5th power, all we have to do is take m, 2 times 5, which is m to the 10th. Again, you don't have to memorize all these rules. If you understand the exponents and why things are what they are, it makes it a lot easier. Think back to the now, okay, the last page we have here is raising a product, which is multiplication, or a quotient to a power. So again, I want to work through these examples and then we'll go back and talk about the rule. So the first one, we have -5x to the 4th squared. Since we have parentheses here, that means we have 2 of these whole things. So -5x to the 4th times another -5x to the 4th power. I put parentheses around the second one because we have a negative there, and anytime you have an operation next to a negative, you always want to use parentheses. Now, by the commutative law, again, keep in mind everything here is being multiplied together. By the commutative law, we can reorder this. So we could rewrite it as -5 times a -5 times x to the 4th times x to the 4th. Now we're back to just simplifying an easier problem. -5 times -5 is a +25. And now in this part here, we have two bases being multiplied, which means you have 4 there, 4 there. So altogether you have x to the 8th power. Also, one thing to keep in mind is always identify your exponent. This is an even number. If you have a negative value being raised to an even power, you know the negatives will eventually cancel out. Okay, let's look at the next one. We have a to the 7th b squared and then a cubed b to the 4th. Now there's no exponent up here, so we can think of the exponent on the outside of this one as just a +1. So now let's go ahead and work through this longhand. We know that we have 2 of those. So we have a7 times b times a to the 7th times b. And then we have 1 of these a cubed times b to the 4th. Now if you need to, you can reorder a to the 7th times a to the 7th times a cubed, and then b times b times b to the 4th. And then we're back to the idea of if you have the same bases being multiplied, you add their exponents. So that'd be 14, 15, 16a to the 17th power. And then we have b to the 4, 5, 6th power. And then the last one, we have 2 of this 3a to the 4th b cubed times 3a to the 4th over b cubed. Oops, cubed. Multiply fractions straight across. 3 times 3 is 9, and that would be a to the 8th power over b to the 6th power. Again, just using all those rules that we talked about before. Now we can say, okay, we did all that by just expanding them, but how does the rule work for here? This is where the idea of the distributing the exponent, or we're able to do it. Looking at the inside the base, we only have products or a quotient. Now we will be distributing that exponent. So for the first one here, let's put a line like this. Let's think of this as negative 5x to the 4th, and we're raising it to the second power. If I add in after this 5 an exponent of 1, what we are doing here is taking this exponent of 2 and we're multiplying it by each exponent inside. So we'd have negative 5th to the second power and x to the 4th to the second power. Negative 5 squared is where we get the 25, and then we multiply those two to get x to the 8th. Looking at this next one of how the rule applies. We have here a to the 7th times b squared times a cubed b to the 4th, and we said that has a power of 1 up there. Again, if we take, actually let's do that using a yellow, that we can keep the colors consistent. We multiply the exponent by each of the exponents, and that b doesn't have an exponent, so we assume it to be 1. And we multiply all the exponents together. So we'd have here a to the 14th, b squared, a cubed, b to the 4th. And then you can rearrange and see the same answer again. The last one, again, this would be 3 to the 1st power, and then you distribute the exponent. So that'd be 3 squared, which is the 9, a to the 4th squared, which is a to the 8th, and 2 times 3 is 6, so b to the 6th. So the rule here is if you have a product, we'll say a times b, and you're raising it to an mth power, you then have a to the mth power times b to the nth power. Same idea, if you have a quotient of a over b being raised to the mth power, you would have a to the m over b to the m because we can distribute it. Again, you're multiplying it by the exponent inside. Now what I want you to do, I want you to pause the video and try these 3 examples. And this ties in all the different rules that we've talked about. If you're having troubles with the rules, try just thinking about what you know about exponents, how can you use the commutative law, and work through them. When you're done, come back and check your answers. Okay, you can see your answers here. Go ahead, you can pause the video, look through them, compare, look at my work. If you need to, then you can replay the video, listen to some explanations, or if you feel confident with it, you're good to go. But just real quickly, I want to walk through what I did here. The first one, there's no outside exponents, so we don't have to worry about distributing anything. So what I did, we know this is all multiplication, so I just reordered it. I put my coefficients out front, and then I grouped my bases that have an m and my base of n together. And then once you have like bases, you can add their exponents to get 10. And that's a positive 10 because you have negative 5 and a negative 2, m to the 7th, n to the 6th. Letter B, we see we have 3 different things. We have coefficients, we have m's, and we have n's. Now, when you look at this one, you see n to the 0th power. You know that's a 1, so you could have right from here, I did not do this, but you could have taken right here this and made that a 1. And then essentially it kind of goes away because we multiply something by 1. It's itself, so you don't have to worry about it. I used it just so you can see how it also works in the problem. 15 over 12, and then I multiply by m to the 6th over m to the 1st power, and multiply by n cubed over n to the 0. Simplify my fraction. 15 over 12 is the same as 5/4 if you divide them each by a 3. And then we have m to the 6 minus 1 over 1, and n times to the power 3 minus 0. which you subtract that, you get 5/4 m to the fifth n cubed. Again, you could have wrote 5m to the fifth n cubed all divided by 4. That would have worked as well. And the last one, you can see that we have 2 of this whole thing. So the first thing I did is I wrote 2 of that whole thing. Now you could have, excuse me, you could have distributed a 2 to all your exponents and worked through it like that. There's more than one way to do some of these more complicated problems. So as long as you get the same answer, you probably did it correctly. If you're unsure if your process was correct, please feel free to take a picture, email it to me, and ask. Anyway, I wrote 2 of these whole things. Now I know that I have a negative times a negative, so I know that's going to be a positive. So I kind of got rid of the negative right there. And then I see I have j to the 0 and j to the 0. Each of those are going to be equal to 1, so I just got rid of them because 8 times 1 is 8, so forth. It gets eliminated. And then I regrouped everything. So in the numerators, I have j to the fifth times j to the fifth times k squared times k squared. The denominator, then, I have 8 times 8, k times k. Simplified that, j to the 10th, k to the 4th over 64k squared. And then I still have 2 k's left that I have to simplify. So I do 4 minus 2 to get j to the 10th k squared over 64. Okay, that's all for 5.1. You can see in this box here, this is just all those rules that we've talked about. It just lays them out. That's from your textbook. Good luck, and let me know if you have any questions. Have a great day. Bye.